Hi, welcome. We're going to go over Chapter 4, Understanding and Comparing Distributions in Statistics. Okay, so let's take a look at these slides that we're looking at today. So, Chapter 4 is all about taking what we've just learned in the last few chapters, chapters 1, 2, and 3, and bringing that now to having like multiple data sets and now comparing them and seeing how they're the same or seeing how they're different. Okay, so let's take a look at comparing groups. Okay, it's almost always more interesting to compare groups. With histograms, note the shapes, centers, and spreads of the two distributions. So that hasn't gone anywhere, and it's going to keep reoccurring. Okay. So what does this graphical display tell you? That's the big question at the bottom. Okay, so let's take a look at this display. You see average wind speed in miles per hour. That's what this is saying. So in the summer and the winter months, they're different. Okay. So in the number of, look at this left one, it says summer. You notice that between 0 and 1 miles per hour, it's like half a miles per hour when you calculate an average for an all-day wind. Okay. You notice it's very high, as in a lot of the days during the summer had not a lot of wind, but then, 1 to 2 miles per hour averages, 2 to 3 miles per hour averages, and 3 to 4 miles per hour averages. Okay. Not many days, but some days had a little bit of wind in the around 2 or 3 miles per hour. Now over here on the winter, okay, we notice it's not as many days that have 0 or 1 mile per hour wind, and it's spread out a lot more. So this left graph we could describe as being unimodal, and it's skewed to the right, whereas the winter one, it seems more uniform from 0 to 4 seconds, and then it kind of cuts off and has like a little small tail at the end that we would say it's skewed to the right also. Where this one's more uniform, this one is more unimodal, and it's stacked pretty high at the beginning, okay? So there's the centers, so that's the shapes. This one's unimodal and skewed right. This one's more uniform, also a little bit skewed right. Okay, so the shapes have that similar aspect to it, but they're different, as in this one is very unimodal. It's just one big mode over here and it goes down, where this one's more kind of evenly spread out. Okay, the centers, right, for this first one for the summer, the center's probably more around here, around 1. Like, where would it balance? Maybe around the 1 marker. Okay, where the winter's probably pushed more towards the 2 or the 3, probably where the center of that is. And then the spreads. Okay, this one only spreads from 0 up to 4 seconds. So that the windiest day, the average wind speed was probably around 3.5 to 3 3/4 or so. Didn't quite hit the 4 mile per hour mark. But for the winter, it went all, the highest, the windiest day was almost 7 miles per hour. Okay, that's how you can compare those two types of distributions. All right, center, shape, and spread, and use those to compare. Oh, and also one thing to kind of note, make sure that they have like a same or a very similar scale. So these are almost the same, right? This one could be put onto here with no adjustments, and this could be put over there with a small adjustment to show like a little extra little stack right there, okay? So you can also do that with box plots, not just histograms. So these box plots, you'd say kind of the same thing, right? The big question is, what do these box plots tell you? What do they tell me is there's a lot of changes going on throughout the year, and over the in the winter into the spring, that's pretty windy. Okay, and then it drops off in May, and then it keeps dropping off, and then by September it turns around into October where the wind starts picking up again. Okay, so to read these lines, these box plots, right, the bottom is the minimum. The bottoms are all pretty consistent. Like every month seems to have some days that aren't very windy. The top parts, though, is the maximum. And the little dots above those are all outliers. Okay, the little stars they call a far outlier. It's really far from the rest of the data. Okay, and there's mathematical formulas to figure that out. Okay, that's just the IQR times 1.5, and then you add it to the third quartile. Okay, that equation looks something like this. So if I had a set of data, take a look. If I had like a set of data with these numbers, okay, the IQR is simply the third and first quartile being subtracted. It's the difference between that space right there, okay? And then find the outliers, right? You find that distance called the IQR, you multiply it by 1.4 or 1.5, then you add it to your third quartile, but you also take that number and you take it away from the first quartile, and that leaves what's called an upper fence, okay? Those are called upper and lower fences, okay? And those fences, any number above that would be an outlier. Any number below that would also be an outlier, depending on which one you're looking at, right? Upper fence, anything above 17 would be an outlier. Anything below 1 would be a lower fence, okay, would be an outlier. And so the data we're looking at just for this little quick sheet, this is a max of 23. But you got an upper fence at 17. That means that 17 would be an outlier. Sorry, 23 would be an outlier because the fence was at 17. Now there might be more, we don't know. We weren't given the full data set. Okay. Once again, the IQR is your first to third quartile. You use that IQR to find your fences, anything above or below the fence, right? Above the upper fence or below the lower fence. That's how you determine outliers, okay, mathematically. If you wanted to go crazy with it and you wanted to find like the far outliers, you would just change this number to a 3, and that would give you a bigger range, right? Because you're going to increase that distance, still adding it to the upper quartile or the third quartile or the lower or the quartile 1. Find like those fences, and those fences would create that little star you're seeing there. So we don't really do that too much in this class, but you might see it in some other classes, all right? Maybe a college professor might use a book that has a bigger focus on it. Okay. All right, so here we are. What does these box plots tell you? So hopefully you kind of can get a picture of what's happening here. The maxes, are kind of big, and it kind of drops off. Everything kind of drops off in May. And through the summer, it's pretty mellow. There's not a lot of wind, but there are some days that are outliers. Okay, and then it picks right back up in October. And once again, even in the winter and the spring, they have their own little outliers. But for the most part, as you see, as the seasons change, so does the wind speed, or the average wind speed for the day in miles per hour. So once again, from January through April, it was in the median and most of their values were increasing. But then once it got to May, it dropped off, and then June through September, that data is really close together. That means your data is really close. It means all your data is really close together. So in July, there wasn't a lot of wind like at all. Okay, in August, it picked back up. In September, it dropped back off. And so what that tells me, everything I kind of described to you, I'd probably try to put that into like a paragraph or something, maybe like 3 to 5 sentences. Okay, talking about the centers. The centers go up. Okay, the shapes. There's some months that are unimodal, or I'm sorry, that are like symmetrical. Okay, but there's some months that are pretty heavy skewed. Okay, but over time, as you notice, it's a wider range in the spring and the winter with higher maxes, but through like the late spring into the summer, you notice that it's a lot more compressed, and the spread is not as much, and the numbers only go up to about 2 miles per hour. Okay, in July it only seems to go up to about 1 mile per hour, or 1 mile per hour. It doesn't have a lot of range in July. All right. So once again with the outliers, if you have outliers and you have your data set and you're trying to calculate your mean and standard deviation, what they suggest, what you should do, is do 2 reports. One report with the mean and standard deviation of all the values, okay, regardless of outliers or not. And then once you calculate your outliers, you remove those from your data set, okay, like save them somewhere else, and you calculate the mean and standard deviation again without your outliers. Just make sure you're clear on how you would write that. You would say mean with the outliers, standard deviation with the outliers. Okay, without the outliers, here's your new mean and standard deviation. Okay. Sometimes you want to work with one, sometimes you want to work with the other. It's just nice to have both accessible. Just a quick note, median and IQR are not likely to be affected by the outliers. The median and IQR are usually not affected at all by the outliers, usually. Okay. All right. Moving on. So, time plots. Order, please. So very similar to the other graphs we see. This new graph is called a time plot. It just says over time, like here'd be January 1st all the way to December 31st, and you see over time each individual data point. It shows you a lot what's going on. Okay, pretty cool. Funny little joke for you. And now, some other topic for this chapter talks briefly about. I don't want to get too much into it because a later chapter will go into more of how to do this. But essentially, just know if you have data that's highly skewed and you want to talk about it, it's highly suggested that you do what's called a re-expression, or you re-express your data, or you do a transformation. Okay, so this is like CEO compensation. So how much a CEO of a company would make in millions. So as you see, most of the data is between, maybe 1 million or hundreds of thousands, all the way up to about 15 million. So it's a big data set. You see a lot of outliers. Maybe it's about 500 numbers or so total. You get maybe about 20 or 30 CEOs that are making these amounts of money that are way above everybody else. And you want to look at that data, but it's so hard to do anything with because it's so spread out. What you can do is simply re-express it or transform that data to look something like the screen graph. That's the same data. Difference is it was re-expressed. This says here they used a logarithm. So what they did was they took every single value, did the logarithm of each and every value, and then graphed it. Okay, they did a histogram with it. And that new data looks a lot more easy to work with because it's unimodal, fairly symmetric, and it's a lot easier to work with. Just know that everything you're working with is the logarithm of that amount. So the numbers you get are not always going to be the nicest to work with. Like you have to do a function to actually do something else with it. Okay, so if you solve for the average of this, you'll have to plug that in, like think of it as a log of something and then undo it, make it look something like on this spectrum right here. Okay, all right. Some things to avoid, right? Good intentions, bad plot. Don't do different graphs with different scales and not a lot of details on it. Okay, it just looks shady, looks weird, looks bad. Make sure the scales are consistent. Okay, also, just make sure you be aware of outliers, but also if you're trying to graph stuff side by side and some of the stuff just gets squished, you might want to look at re-expressing the data so that it's all kind of similar. Okay, transform it so that they all look kind of the same, and then that way point out like the centers and the shapes, and the spread's much easier. Okay. So that's it. It's kind of a short chapter. Hopefully that all kind of made sense for you. Hope you have a good night, and hopefully this kind of made some sense. All right, have a nice day.